A good day to everyone who's watching. In our lesson today, we are going to talk about equations involving indices. Example 1. Solve for the unknowns in the equations below. Part A, we have x power third is equal to a 3 there. Now, we are going to find ways of eliminating that power a third on x such that the x can have a power 1. The x is the unknown in that equation there. Recall in O-level indices that root of x in index form, this one we expressed it as x power a half. So this x power a third, we can call it the cube root of x, which is equal to a 3. Now, also recall when we had the square root of an unknown and we had some value there, that when we wanted to kill that root, we squared both sides such that the square cancels with the square root. So to kill this cube root that is on x, I'm going to cube both sides of the equation such that the cube here cancels with the cube root, and then I remain with x to be equal to 3 power 3, and when you raise 3 to 3, we get 27 there. So alternatively, even if you don't convert that index form to the cube root, but if you want to eliminate that power a third, both sides, that means that you need to raise the powers of either side of the equation to 3. So when I cube this side and also cube that side, when we open the bracket there, in lesson 1 we said that the powers are going to multiply each other, then this is 3 cubed. The result of this here is going to give you x power 1, and it is equal to 3 cubed. X power 1 is x, 3 cubed is 27, just like before. The part B, we have m raised to 4 all over 3 is equal to 81. Now, we need to kill that power 4 all over 3. That is, we are going to raise the powers of the bases on the either side to 3 all over 4, such that when you open the bracket, this one gives us a 1. And we know that any number, power 1, is that very number. So what I'm going to do here, I'm going to raise this side to 3 all over 4 is equal to 81, also raised to 3 all over 4. When I remove the bracket, 4 all over 3 is going to multiply 3 all over 4, which is equal to 81 power 3 all over 4. This one here is the one that's going to give me m power 1, and this one is equal to, this 81 is 3 power 4, then into 3 power 4. So when I open bracket that side, I'll be having 3 power 3, and this one is equal to m. Then the 3 power 3 is the same as 27 there. We have our part C there. 2k, the k raised to 3 all over 4 is equal to k raised. Now we are going to first collect the k's on one side. That is when I divide both sides by k power a half. So this is 2k 3 all over 4 is equal to k power a half. So when I divide k power a half that side all over the k power a half this side, I can also divide to both sides there. Then this side I'm having the k power 3 all over 4. Then since they are dividing each other, I'm going to subtract the powers, and this one is equal to 1 all over a 2 there. So when I subtract the powers, the LCM is a 4 times 4 and then times a 4 there. So this one here gives me a 3, then minus this one here gives me a 2, and then that is 1 all over a 4. So this is k raised to a quarter is equal to a half. So now to kill the index a quarter on k, I'm going to multiply the powers of the bases by 4 such that the 4 can cancel out with the a quarter. When I open the bracket here, the 4 is going to multiply the a quarter such that you have k power 1, and this one is equal to, in index, when you remove the bracket, these bases in the numerator and the denominator, they will all take up that power of 4, but 1 raised to 4 is 1, and 2 raised to 4, 16. Therefore I have my k as 1 all over 16. Part D. In O level, we used to have such an equation, and then we said you are going to prime decompose, that is the right hand side, such that it can have a base of 3. Then from there we equate the powers. So when I prime decompose 27, this is 3 power 3, then into 2x minus 1. Then the next step is to equate the powers there. So this is x plus 2 is equal to 3 into 2x minus 1. Then opening brackets on the right hand side, so that is 6x, then minus a 3, then x plus a 2. Collecting like terms, that is the 2 plus 3 is equal to 6 minus the x. When this goes the other side, becomes a negative. Then this one coming this side takes up the positive. So this side I have a 5, and the other side I have 5x. Then I just need to divide both sides by 5 to get the value of x as a 1. Part D, we are still finding the unknown. When you look at this equation in part E, we need to first prime decompose 4 and 8 there. Then after prime decomposing them, we need to convert them back to the numerator. So this is 1 out of 2 squared, then power n, then times 2 power n plus 1 is equal to 1 all over 2 power 3. So everything has a base of 2. Then I'm going to convert this back to the numerator, and even this back to the numerator using the a power n is equal to 1 out of a power n. So this one here is going to be 2 power the negative 2, then there is still a power n outside, times 2 power n plus 1, then is equal to 2 power a negative 3. Opening the bracket here, that is 2 power negative 2n, then times 2 power n plus 1 is equal to 2 power a 3. Multiplying numbers of the same base, we are going to keep the base and then we add the powers. So this is 2n minus 2n plus n plus 1 is equal to 2 power negative 3. Then now I'm going to equate the powers there. So that is negative 2n, then plus n plus 1 is equal to negative 3. Taking the 1 the other side, it's going to be minus 3, then minus 1. Then here I'll be having a minus n. Then finally the minus n is going to be equal to the minus 4. Then I divide both sides by a negative 1 such that I have the n as a positive 4. Part F, we are also still finding the unknown there. We are going to make the right hand side to be having a base of 5. The 125 is the same as 5 power 3. The root of 5 is the same as 5 power a half. So this one is the 5 power 3, then times 5 power a half. Multiplying numbers of the same base, we are going to keep the base, then add the powers there. So when you add these powers, 3 plus a half, LCM is a 2, then times 2 there, so that is 6 plus 1 to have 7 all over a 2 there. So this is 5 power m is equal to 5 power 7 all over 2. Then we equate the powers and we get the value of m as 7 all over a 2. So this is the end of our lesson. We always end it with an exercise. Now the dots that you see here, here and there, they mean multiplication. Please don't forget that. Then also you can share the link of this video to your friends, share the knowledge, and then you can also contact me on WhatsApp.